As it says up here, acid base is defined by the transfer of protons. And acids and bases are super important chemically, biologically, biochemically, commercially. Even before chemistry class and way before AP chemistry, you had heard of acids and bases and probably neutralization. So we can define something as an acid based upon the way it tastes, based upon its pH, based upon the way it reacts. Really, the simplest definition is the Arrhenius definition, that it starts with an H or it ends with an OH. But the definition that we focus on the most is the transfer of hydrogen ions, because that's what helps us to really understand how or why a reaction is occurring. And that's the Bronsted-Lowry definition. So the Bronsted-Lowry definition of acids and bases is about the exchange of protons. The acid donates or gives away its hydrogen ion, and the base takes it in. So here, rather than defining them by themselves, we're looking at it in terms of the reaction or in terms of that exchange. To have an acid, you have to have a base. To have a base, you have to have an acid. And in doing that, we also make products. Those products, after we've given away our hydrogen ion, we don't have it anymore. Now it has the ability to take that hydrogen back. It may do it very well or very poorly, but the acid will always turn into a conjugate base. And conjugate here is the way that we say that, but we can also think about it as conjugating, like conjugating a verb, like you might do in English or a world language class, where we're taking something and we're changing it into its other form. So we're taking our acid molecule and turning it to its base form, kind of like, the different pronouns you might use with something or different tenses. We've got a base. After it gets that hydrogen ion, now it has more hydrogen. Depending what it goes with, or depending on the circumstance, it may give that back away. So it has conjugated itself into an acid. So we'll come back to this, and it says this lots more later because we have a whole topic devoted to just acids and bases, but we really need to practice and start getting these down. And because we're always looking at things in terms of how they can exchange them, there are certain substances that can either donate a hydrogen ion or accept it, depending how acidic or how basic something is with it. And an example right here would be water. In this case, water is with sulfuric acid, which we know by its name and by definition to be an acid. So in that case, even though water doesn't necessarily have a super high pH or taste bitter like we define bases as doing, it acts as a base by accepting it, and then it's conjugated to its acid form. And this is our conjugate acid-base pair. The sulfuric acid conjugates itself into a base form. When we're talking about acids and bases, the Bronsted-Lowry, the donor and acceptor definition is the one that we'll use, but the other words we use a lot is strong or weak. Strong and weak have to do with how well they break apart or how well they ionize in water. It's really a spectrum, with some being very, very strong and pretty strong, and the ionizing can go anywhere from 100% down to about 1%. So it really is a spectrum. When we are defining them for this class, we have the list up from before: hydrochloric, hydrobromic, hydriodic, nitric, sulfuric, and perchloric. Those are the ones that we treat as strong, and we treat as if they ionize 100% and as if they're all equal to one another. For bases, we do the same thing with the hydroxides of alkali and alkaline earth metals. The weak ones still break apart, but not quite as much. And when we're looking at Bronsted-Lowry, we start to get a feel for that. How good are they at giving their hydrogen ion? How good are they at accepting a hydrogen ion from something else? So we've got that idea right here. And in acid-base equilibrium, we'll look at those properties in a lot of detail. But right now, we're just understanding how that hydrogen ion can go back and forth, which would help us to understand our reaction and define something as either an acid or a base.